Hey guys, my name is Shreyas and welcome to Simple Chemistry. In this video we're going to be discussing the 5 basic types of reactions. Okay, so the first one is a synthesis reaction. It can also be called a composition reaction or a combination reaction. It's where 2 or more reactants combine to form one product. Here's an example. So we see 2 or more reactants, hydrogen and oxygen, combining to form one product. You can think of synthesis means like building up things, so that's a good way of remembering it. This is being built up from 2 smaller parts. Decomposition is the opposite. It's when one compound is broken down into 2 or more compounds. Here's an example. You have aluminum oxide being broken down to aluminum and oxygen. Combustion. So combustion is a little bit more complex. It's when a hydrocarbon, or that's a compound consisting of only hydrogen and carbon, or a carbohydrate, that's a compound consisting of only carbon, hydrogen, and oxygen, reacts with oxygen to form carbon dioxide and water. So this is typically the things you see whenever you're seeing something being burned. It's typically a combustion reaction. So here's an example. You're seeing a hydrocarbon here because this is a compound consisting of only hydrogen and carbon. There's only hydrogen and carbon within this compound, and it's reacting with oxygen. It's reacting with oxygen in order to form carbon dioxide and water. Okay, so that's a combustion reaction. A single displacement or replacement, same thing. It can be called single displacement or single replacement reaction. Is when you have an element in a compound, and then they react, and you get a different element in a different compound. So basically, you have A plus BC, and then there's kind of a flip. So B flips with A. Here's a good example of that. So as you can see, you have the element here, fluorine, and that's reacting with potassium chloride, and then you see a flip, right? So the chlorine flips with the fluorine, and the potassium is still there. So that's a single displacement. Now a double displacement is when you see a flip between 2 compounds. So AB plus CD flips and you get AD plus CB. So if you see here, you have silver nitrate reacting with potassium chloride, and then the nitrate flips with the chlorine. So both of them flip, and you get 2 different compounds. You have silver chloride and potassium nitrate. Okay, so those are the 5 basic types of reactions. Now let's actually have a little bit of practice writing these reactions out. So write out and balance the chemical equation for this reaction. So we have solid aluminum reacts with oxygen gas. So solid aluminum, and if you want to indicate it's a solid, we can put this. Reacts with oxygen gas, and remember, oxygen is a diatomic element, so it's always 2. Let's have a brief review of what the diatomic elements are. So in nature, hydrogen, oxygen, fluorine, chlorine, bromine, and iodine are always found as 2. You never see any of those alone. They're always found as 2. So whenever you see oxygen gas, it's always in the diatomic form. So it reacts with oxygen gas to form solid aluminum oxide. So we know that aluminum oxide is, you have to know nomenclature for this. So if you don't, then you're definitely going to struggle. So make sure you watch the nomenclature unit before watching this whole series of videos. But anyway, so aluminum oxide is, we know from the nomenclature unit that aluminum always has a charge of +3. So, and oxygen always has a charge of -2 because it's in this column of the periodic table. So we flip that and we get aluminum oxide to be Al2O3. And that's a solid. Now if you want to balance this chemical equation, let's go ahead and try to do that. So look at the most complex compound, that's this, obviously. So there's 2 aluminums here, there's only 1, so we can put a 2 here. And then we run into a problem, because we have 3 here and then we only have 2 here. So what we can do, we talked about this in balancing chemical reactions, is we can put a 3/2 here. because 1.5 times 2 is 3, and then we can multiply the whole equation by 2, and we would get 4 Al solid, aluminum solid plus 3 O2, and that will give us, and then here 2 Al2 O3 solid. Alright. Okay, let's move on to the next problem I have here. So a decomposition reaction. So we're going to write out and balance the chemical equation for this reaction. Hydrogen peroxide in solution decomposes to form liquid water and oxygen gas. So hydrogen peroxide in solution. Hydrogen peroxide is H2O2. Excuse me. In solution, so to indicate that, we're going to write aqueous like this. Decomposes, it's going to break down to form liquid water. So that's H2O. And in order to indicate it's a liquid, you're going to do this. Plus gaseous oxygen. Again, oxygen is a diatomic element, so it has to be 2. So now let's try to balance this out. So there's 2 hydrogens here, and there's 2 hydrogens here. That's great. But then there's 3 oxygens here on this side. So what we could do, let's try to put a 2 here. So now we have 4 oxygens here, and then if you put a 2 here, we have 4 oxygens here, and then the hydrogens are also equal to 4 hydrogens here and 4 hydrogens here. Great. Okay. So we have that. Let's move on. We'll keep moving. Write out and balance the chemical equation for this reaction. So solid glucose reacting in a combustion reaction. So remember, a combustion reaction is a carbohydrate or a hydrocarbon. This is actually, in the example we saw, that was a hydrocarbon because it had carbon and hydrogen only. This is a carbohydrate because we have carbon, hydrogen, and oxygen only. And so remember, let me move back up here. It's a hydrocarbon or a carbohydrate reacting with oxygen to form carbon dioxide and water. So we have to memorize that. So we're going to have the carbohydrate here. And it's solid, so we can indicate that. Reacting with oxygen, which is a gas, and to create carbon dioxide and water. Let me rewrite that. I ran out of room. Let me rewrite that so we get more room. So again, we have solid glucose here. And that's going to react with oxygen to form carbon dioxide and water. And the carbon dioxide, I forgot to indicate that, it's going to be a gas. Because of all the heat, it's going to be a gas definitely for sure, as well as the water. That's probably also going to be in the gaseous state because of all the heat from this reaction. Okay, so we have this. Again, combustion reaction is a carbohydrate or a hydrocarbon. This is a carbohydrate reacting with oxygen to form carbon dioxide and water. So we have that. Now let's go ahead and balance. So we focus on the most complex molecule. That's this for sure. There's 6 carbon atoms here. There's only 1 here. So we can put a 6 here to balance that out. For the hydrogens, we have 12 hydrogen atoms here. We only have 2, so you can put a 6 here to get 12. And then for the oxygen atoms, we have 6 times 2 is 12, plus 6 is 18. We have 18 oxygen atoms here. We have 6 here, plus 2, that's 8. So if you can subtract 6 from this, we have 12. And then if you put a 6 here, the oxygen atoms balance out. So 6 plus 6 times 12 is 18. Here we have 12 plus 6 is 18. So great, we have this. Now let's do this. A single replacement reaction. So write out and balance the chemical equation for this reaction. So that is silver nitrate reacts in solution. So silver nitrate is this. And since it's in solution, that's I'm going to indicate that with the aqueous like this. Reacts with solid copper, okay? So we know from a single replacement reaction that the elements are going to flip. So what's going to happen is that the silver here is going to flip with the copper here. So we're going to get silver left out, like this. And that's probably going to be a solid. And then we're going to get copper nitrate. I'm just going to say copper 2 nitrate. You can't be exactly sure. Let's just say it's copper 2 nitrate. And that's going to be in solution. Oh my god, I can't write an A properly. Okay. So as you can see, we have the single replacement reaction with this element flipping with this element, and it's very simple. Now we can go ahead and balance. We have two nitrate groups here, so we can just put a 2 here, and then we can put a 2 here to balance out the silvers, and everything will be balanced out. Okay, and finally, practice with a double replacement reaction. We actually have two problems here that I want to point out. So lead nitrate in solution, lead 2 nitrate, which is PbNO3 2 in solution, reacts with potassium iodide in solution. So with a double replacement reaction, we see this is going to flip with this. The nitrate is going to flip with the iodide. So we're going to end up with okay, so let's indicate this. Since this lead has a +2 charge here, and the nitrate has a -1 charge, and the potassium here has a +1 charge, and the iodine has a -1 charge. Okay, let me first explain where I got these charges from. For the lead charge, I already got that since it's lead 2, we know it has a +2 charge, and we know for nitrate always has a -1 charge. And for this, we know that potassium always has a +1 charge because it's in this column of the periodic table, and iodine always has a -1 charge in its ionic compounds because it's in this column of the periodic table, okay? So when this flips, we have to account for charges. So nitrate is going to flip with iodine, so we're going to get PbI. Okay, but since the lead has a +2 charge and this iodine has a -1 charge, we're going to need to have 2 iodines to bounce the charge out. I'm not going to really worry about if it's going to form a solid or a liquid. We'll get to that later, way down the road in solutions. Let's just focus on the compounds first. So we have that. Okay, plus, and then the nitrate's going to pop over here. So you have potassium, and we have nitrate. And since potassium has a +1 charge and nitrate has a -1 charge, the charges will balance out, and we have one of each. Okay, now let's go ahead and balance this out. Since we have 2 nitrates here, we can just put a 2 here to get everything, 2 nitrates here. And then then that's going to cause us to have 2 potassiums. So if we put 2 potassiums here, the potassiums balance out, and that in turn is going to balance out the iodine, because you have 2 iodine here and 2 iodine here. Okay, now let me go ahead and erase all of this because we can work on our second problem. Okay, so this is, let's just ignore this, the in solution part. Let's just focus on the compounds. So we have lead 3 chloride, and that's FlCl3. The way I got that is because I know iron is going to have a +3 charge. Chloride always has a -1 charge because it's in this column of the periodic table. So +3 -1, there needs to be 3 chloride atoms to balance out the charge there. You should be very familiar with doing this, because we talked about this in nomenclature. If none of this is making sense to you and it's too hard, I highly suggest you go watch the nomenclature unit first. Okay, and that's going to react with barium hydroxide. So barium, since it's here, it has a +2 charge. Hydroxide has a -1 charge, so that means we're going to need to have 2 hydroxides in order to balance out with the +2 charge of the barium. So let's go ahead and indicate that. So that's barium hydroxide. Great. Let me go ahead again and write out the charges. So when we +3 -1 +2 -1. So when we flip, then we're not going to have any issues with charges. So the chloride is going to flip with this part here, the hydroxide. Okay, so that's going to leave us with iron hydroxide, iron 3 hydroxide, and since the iron has a +3 charge and the hydroxide has a -1 charge, we are going to have to account for that by saying there's a 3 here, so that everything is balanced out. +3 -3, everything's good. And then the other part is the barium. Since the chloride came here, now we have barium chloride. And barium has a +2 charge, chloride has a -1 charge. So we're going to need 2 chlorides to balance out that charge there. Okay, great. Now let's actually balance this chemical equation. I think the best way to do that here is, since there's 2 hydroxide groups here and there's 3, we can just flip. You can put a 3 here. Let me use a different color. A 3 here and a 2 here. So at least the hydroxide groups are settled. And then, so now that we have 3 bariums here, we can put 3 bariums here. So that's going to give us 6 chlorides. And we have 2 irons here, so if we just put a 2 here, then everything is set. Let's just check here. We have 2 irons here, 2 irons here. We have 6 chlorines here. We have 3 times 2, 6 chlorines here. We have 3 bariums here. We have 3 bariums here. And we have 3 times 2, 6 complete hydroxide ions here. And we have 2 times 3, 6 complete hydroxide ions here. Okay, that was a lot of work, but this is important to know because sometimes a question is not going to give you just the chemical equation written out nicely for you. It's going to say something like this. It's going to say it's a double displacement reaction between these two things, and you're going to have to figure out what exactly the chemical equation is. So this is an important skill to have. I know I went kind of fast. So, you know, if you didn't understand anything, make sure you go back, rewind, and watch it all over again. But those are the 5 basic types of reactions that you need to know. It's as simple as that.